One might have imagined that even through the training of a machine learning, even though the training of a machine learning system might be circuitous, somehow in the end, the system would do what it does through some kind of identifiable and explainable mechanism. But what we'll see is that, in fact, that's typically not at all what happens. Instead, it looks much more as if the training manages to home in on some wild computation that just happens to achieve the right results. Machine learning, it seems, isn't building structured mechanisms. Rather, it's basically just sampling from the typical complexity one sees in the computational universe, picking out pieces whose behavior turn out to overlap what's needed. And in a sense, therefore, the possibility of machine learning is ultimately yet another consequence of my favorite phenomenon of computational irreducibility. So why is that? Well, it's only because of computational irreducibility that there's all that richness in the computational universe. And more than that, it's because of computational irreducibility that things end up being effectively random enough that the adaptive process of training a machine learning system can reach success without getting stuck. But the presence of computational irreducibility also has another important implication, that even though we can expect to find limited pockets of computational reducibility, we can't expect kind of a general narrative explanation of what a machine learning system does. In other words, there won't be a traditional, say, mathematical general science of machine learning, or for that matter, probably also neuroscience. Instead, the story will be much closer to the fundamentally computational new kind of science that I've explored for so long and that has brought us our physics project and the Rouliad. So in many ways, the problem of machine learning is a version of the general problem of adaptive evolution as encountered, for example, in biology. In biology, we typically imagine that we want to adaptively optimize some overall fitness of a system. In machine learning, we typically try to adaptively train a system to make it align with certain goals or behaviors, most often defined by examples. And yes, in practice, this is often done by trying to minimize a quantity normally called the loss.